Well, hello, and thank you for standing by. My name is Thomas, and I will be your host today. Thank you for joining our second virtual strategy day, Germany, Austria, and Switzerland today. I specifically mention second virtual strategy day because it's not our second strategy day. So I think it's our fourth, fifth, or maybe even sixth strategy day already. But due to the current situation, it's our second one. And I personally hope that when I will do the announcement for our next strategy day, I don't have to use the word virtual, but we can all meet in person again with a glass of wine or a glass of beer and have some fun together. Nevertheless, we will have a lot of fun today with a great program. And I'm very excited to discuss the topic of Zero Trust security with all of you. So for the benefit of all of you, my name is Thomas. I'm the Regional Vice President for Germany, Austria, and Switzerland here at HashiCorp. What that means is that together with a really, really great team and lots of great partners, we now have helping us to spread the message of HashiCorp here in the region. I will be having the honor of guiding you through this journey today. So a tradition of every strategy day also always is to give you a little bit of a behind the scenes view of what's happening HashiCorp internally. So 3 years ago, we were exactly one person helping out here in the region, putting the HashiCorp flag up. And that grew throughout the last 3 years, up to 25, very soon 30 people who are supporting our customers foremost, but also our partners here in the region to implement the great HashiCorp tools. We have an excellent sales team who will be helping our customers in all commercial questions they may have. But we also have a really, really brilliant technical team who also is on the call today. So if you will have any technical questions, please also use the chat. You can use it in English, you can use it in German, whatever you prefer. And there are people who can help you with questions you can raise to the audience, but also maybe some questions we can answer in the back end. Besides that, we have a team which is taking care of our partners. We have a proper marketing team in the meantime. So I'm really, really proud of that we are growing here in the region as well as HashiCorp is growing worldwide. But not only we internally here at HashiCorp are growing, we are also growing our partner network. And our partner network is especially important to us as we personally, with these 30 people, can't cope with the demand of HashiCorp and the HashiCorp offerings. So it makes a lot of sense to involve and talk to one of our partners you see here on the slides, because they do not only have the possibility to resell our software, but foremost and mainly they have the expertise in implementing and consulting you on our software stack as well. They also have expertise in other tools who are very closely used next to the HashiCorp tools, and therefore really know and can guide you on how to build a really good architecture so that everything fits together. So also thanks a lot to our partners supporting us here. You see the slides and the logos here on the slides. I'm not going to mention them all, but what you may be wondering is that we also have the big cloud partners here on the slide at the bottom right, like Azure, AWS, and Google. And this is especially interesting also to our customers because there also is a possibility now that our customers can procure our software via the specific marketplaces on Azure, AWS Marketplace as well as the Google Marketplace. So quick outlook on this, but now let's have a look at the agenda and let's have a look what we will be doing today. So first of all, we will have Guy Sayar as a main speaker. Guy is the HashiCorp field CTO for the region here in EMEA, and he will give us an introduction of what for HashiCorp means Zero Trust and how customers ideally implement it. After that, we have an external speaker, which is Jens Dose, and he is an editor at IDG and also a writer. And he will give us an external view of Zero Trust, what the market thinks about it, what externals understand from that topic, and also give us a little bit of a guideline and best practices, how organizations ideally implement that nowadays. And after Jens's presentation, we will have a panel discussion where again, we will have Jens on the panel, where we have Guy on the panel, but we also have two additional speakers. And one of them is Conrad, and Conrad is from Microsoft, and there he is a partner technology strategist and also gives his view on Zero Trust, what he experiences at Microsoft and at Microsoft's customers. And we have Ingo, which I'm also really proud of that he's joining us today. Ingo is working for SAP. Ingo is one of our customers, and Ingo is a development manager at SAP, just sharing his experience. After the panel discussion, which I think will be super, super interesting, and feel free to ask any questions you may have via the chat, we will have Lance Haig with a presentation around the HashiCorp Roadmap on Zero Trust. Lance, for those of you who don't know Lance yet, Lance is heading up our technical team here in Germany, Austria, Switzerland, and that will be a really interesting presentation as well. As I mentioned a few times already, there is a chance to ask any questions all the time during the chat, but we have reserved some minutes at the end of today's session to go through these questions and hopefully answer most of them. And after that, I think it's super important to mention that we will have an after-event party. So for those of you who registered to that event, which should be everybody, there was also the possibility to register for the after-event party. And if you have done so, you should have received a little package from us with some drinks and some snacks. If you missed that chance, but think it would be still good to join the after event party, where you will have the chance to talk to all the panelists and to all the presenters today, and just to share and collaborate a little bit, feel free to do so. We will later on post the link here in the chat again, and just join. It will be a separate link. What's maybe also important to mention is that this webinar is being recorded, and that the webinar recording will be made available after post-processing, which usually takes around 2 business days. So with that, let's jump right in, and I will turn over to Guy. Guy, are you there?
Everybody, thank you, Thomas. Hi, everybody. I'm Guy, and I'm going to start my talk on Zero Trust. I'm going to start with actually taking a look at where we are today, mostly with on-prem existing data centers and the high trust networks that corporates manage, and then a little bit about the transition and the impact of moving to cloud, which is a main driver from our perspective to Zero Trust. And in this last section of the talk, I'll cover our approach with our products for implementing Zero Trust successfully. But just before we start, for those who are not familiar with us yet, we operate in the cloud infrastructure and automation domains. And our product portfolio addresses provisioning, securing, connecting, and running use cases for managing applications in a multi-cloud environment. And today we're focusing on the securing part, that is Vault, Console, and Boundary. Right, so we'll start by looking at how traditionally how data centers are secured, on-prem data centers, right? And we kind of say easy, quote unquote, but rather I should say it was sufficient to secure the data center at the edges, right? Because we believe that we could kind of, identify and block bad actors in a very, very clear way. We could, we had this model of anyone outside of the data center is a bad actor. Anyone inside the network on the data center is a good, trusted actor, right? And with this model, the entire focus is on the ingress, controlling the entry point into the data center. And that would be with firewalls and WAFs and SIEM middleware and whatever else. And then sometimes we'd also have different segments or near DMZ and far DMZ with reduced functionality, and all that basically to stop bad actors from gaining access to the core network and the on-prem data centers. And we could actually do that. Organizations could do it because we had full control over everything, starting from the walls, the physical infrastructures, the network gear, the cables, and everything else up to the entry point into the data center. Then there was kind of notion of, if we carry on and thinking of that model and layer application teams on top of it, we kind of gotten used to, application teams gotten used to security being done by someone else, right? It's someone else's problem. There's a different team that runs in parallel to the application and the infrastructure team that will secure the environment, right? And then, thinking of taking it even further, when application teams went through cyber reviews and penetration testing, and application owners could look at the findings and practically or logically speaking, accept the risk to avoid delays and kind of move on, then go back to address these findings, almost like addressing technical debt in a way, or accepting technical debt. And that was all okay, that was all fine, because we fundamentally assumed that securing the perimeter was sufficient, right? The perimeter is secure, the data center is secure, the network is trusted. And with that model, it was okay for applications and infrastructure teams to be less strict about security. And then came cloud and basically changed all this model, flipped it on its head, and we'll talk about why that is. And there are many things that change when we talk about cloud adoption. In the context of Zero Trust, I want to call out three main areas, right? The first area is that with cloud, and more so with multiple cloud, the network is no longer a physical construct. It's a logical construct. We don't control the underlying network gear. We don't control the cables. These are owned and managed by cloud providers. And rather, we consume the network, we send directives and kind of create virtual network that spans multiple providers, multiple venues, multiple regions, and so on. And then if we layer cloud adoption into that model of logical network and think about core applications that will forever remain on-prem and probably die on-prem, we can also think about applications that will be refactored to be migrated to cloud, and usually net new applications that are just deployed on cloud. We now have this requirement, this new need for access and connectivity between internet, low trusted environment, and our on-prem high trust network, right? So our understanding of the perimeter is completely changed. The second is the increased focus on developer experience, the agility, speed, self-service to enable application teams, right? So now think of cyber teams kind of changing from being a gatekeeper, usually at the end of the process, to becoming an enabler, right? think about it as the shared responsibility model. And in that model, the cyber teams define and govern policies, and then basically move out of the way for application teams to implement and comply with, right? So now we don't have cyber to control every change. We need to think about a different way to ensure that the organization and applications are safe in our data and everything else, right? And that is done with increased application involvement. Security and cyber can no longer be transparent to the application. And then the last point is that we need to assume breach, right? The assumption that anyone on the network is trustworthy, they have good intentions, that no longer holds. And we need to assume that anyone on the network is a potential attacker, and they gain no access and no visibility into anything until they kind of prove their intent. So then how to change, how to adapt to the new reality with cloud from a security perspective. And here too, I'm going to call out 3 main areas that we focus on. The very first thing is we kind of change our control point, and we move away from using network identity, IP addresses, right, from being a form of identity to managing identity at a different level. Think of the network. We talked earlier about physical and now logical, and spanning multiple providers. They will have overlapping IP addresses. They will patch IPs. Some new technology stacks will hide IP addresses completely and present you with a different IP, NAT or Kubernetes or whatever else, right? So we need to move away from having IP-based control, identities and control, to having a logical identity and control model. And the way to do it is basically to elevate the identity, define it at the service or application level, and then realize it with physical network as it happens, but use policies at the service level and not at the physical level. The next thing that we want to look at is how we manage secrets, how we manage credentials, and then think of the spectrum of starting with hard-coded username and passwords, config file and source code, and then to the very far end of the spectrum where we use one-off identities, one-off keys, one-off passwords, right? So this is a nirvana state where once an identity has been used, an API key has been used once, it is completely useless, no longer valid, and that the attack vector has completely vanished, right? So we know, we're kind of going there and moving from the hard-coded to dynamic secrets, dynamic ephemeral identities is something that we want to invest in this journey, right? So exactly as workloads and data and infrastructure, they're all ephemeral, we also want identities and secrets to be ephemeral. And then the last point is encrypt everything, right? We kind of move away from this notion of transparent disk encrypt that is done automatically and the application doesn't see it, which kind of protects from physical access to the disk. And then we have physical access to the disk, you will not be able to see the data. But in our new zero trust environment, you gain access not physically to the disk, but through the network, through the database, or through an application that you breached. And that data that has been encrypted transparently will also be transparently decrypted, right? So we need to think about it in a different way. This is where we elevate it a little bit to the application, and the application will be aware and participate in the encryption. Data at rest, data in transit. This is where application to application and application stores and reads encrypted data and does the decryption in memory. All right, so now, with those fundamental changes and how to adapt to the new reality, I want to cover a little bit how HashiCorp approaches the zero trust and how our tools are used to implement zero trust. I'll cover Vault, Console, and Boundary. So we break the problem into 4 different areas. The overarching principle here, and this is the single most important point of this talk, is the move from the transition from IP-based control to identity-based control. Right, and you'll see that I'll repeat this with the various tools. We move away from physical network, IP addresses, to service application identity that is ephemeral and transit. And we implement machine to machine a little bit differently to human to machine. The requirements are similar at the high level, but when you get to the detail, you'll see that we need different tools to implement these workflows. And I'll start with the edges and kind of walk inside. So I'll start with human to machine authentication and authorization, and this is where we kind of use the workflow that has been established and evolved over the years to implement what we know as single sign-on. Right, typical journey starts with authenticating against an LDAP or an Active Directory or Kerberos, and then that identity is carried to the target venue with a single sign-on platform like Okta or Ping or whatever else. And really with cloud, there's not much new here. We use the same mechanism and we piggyback and carry that identity into the cloud. Now going to the far end, I'll talk about the authorization and authentication for machine to machine. This is where we use Vault. And Vault, is one of our fundamental and security products. It solves three main use cases. Right, the first one is the secrets management. We talked earlier about the need to move from hard-coded to one-off, eventually, identities and passwords. This is where Vault comes in, typically starting with using it as a wallet to store static credentials and then enhancing the use. And the second and third use cases are about data protection. And this is where the need for elevating data security and encryption from being done transparently to being done at the application level. We use Vault for applications to encrypt and decrypt data, and then also use it to secure data in transit. And in the context of Zero Trust, this is kind of a summary on Vault, right? It's our identity broker, right? This is the central functionality for Vault, is to hide all the complexity that comes with managing multiple identities, well-known or ephemeral, between different venues. So application usually starts with authenticating against Vault with a well-known identity, and then Vault will enforce policies and make sure that the request can go forward, and in such case would broker the identity, present it with new credentials, ephemeral, in the target environment. Okay, so now we know who we are. We have established identity. We know that we can trust that entity that we want to talk to, and then we need to talk about securing the access, the communication between different entities. We'll start with machine to machine, and then eventually we'll also talk about human to machine. So machine to machine, we use Consul, right? It's our service networking solution. We use it to automate network workflows in a secure way across any cloud and any technology stack. Consul 2 solves three main use cases, and you can think about them as kind of a walk, crawl, walk, run approach that we do with our products. The very first one is the service discovery. So think of Consul as holding a holistic service view, a registry of up-to-date location and health status of deployed services, right? And then exposing it with a DNS view or something else. And then typically also used to automate CMDB updates, right? This is going to be a feed from Consul to update the existing slower moving infrastructure. The next use case is the service mesh. And service mesh, in essence, is where kind of decentralize the security, right? The security and indirection functions that are typically managed centrally with appliances, we now decentralize them and have Consul enforce them at the edges, right? Enforcing access and connectivity at the edges with mutual TLS for intra and inter-cloud communications. And then the third use case is the application infrastructure, the network infrastructure automation, in short, NIA. And this is where Consul integrates either directly or through Terraform with those appliances to complete the last mile of automation. Right, so we talked about the decentralizing and kind of doing security at the edges. That's all great. That's good for the new world. What we see is that in the existing world is a gap, we call it the last mile, where everything is automated up to the network gear, right? The firewalls and the load balancers, they still sit behind slow-moving ticket processes. So think of Consul enabled by Terraform, updating those appliances automatically as the environment changes, right? With no human access. So it's the triple Z, right? It's a zero trust, zero touch, and zero downtime. I like the triple Z approach. And yeah, I see this triple Z as a real game changer. It's the first time that we kind of see the entire flow, including the last mile, automated completely without any human involvement. To summarize, Consul, it's the solution for machine-to-machine access, right? The guiding principle here is application-based networking, moving away from physical to application and service networking. I'm going to talk quickly on the last bit. Last but not least, this is the human-to-machine access. We use Boundary here. Boundary is a new product. It's available as open source, and I'll talk quickly about what Boundary does. Here, I want to walk through quite swiftly on the existing workflow for human-to-machine access, and kind of, looking at some of these challenges, right? So typically a human would access a VPN. It's a moving part with some sort of device that needs to be distributed for key, RSA rotating key or YubiKey or whatever else. And it's a slow, costly and risky onboarding, and even more so offboarding. And then once you've passed the VPN, you are at the network. You have access to the entire network, which is kind of fine, but in a zero trust, it's also not fine, right? You don't want people walking around the network and doing stuff. The next bit, after you've kind of been there, is you need to pass some gate, typically a firewall. We talked earlier about the IP controls and being brittle and change as the environment changes. These firewalls need to be updated, or IP tables or jump host or whatever else. And then lastly, the last part is that the user needs to be known and have credentials to the resource. Right. So we kind of looked at this approach, and we saw this is a great approach for a slow-moving, high-trust environment, and we wanted to solve the same problem and make it with less friction, but with higher trust. Right. So I'm just going to quickly cover these points and see how Boundary helps. The first bit is there's no VPN, right? The access is protected with single sign-on, the exactly same single sign-on that the organization uses. No additional onboarding or offboarding. Then there's no access to the network. Kind of see a list of services or resources that you're allowed as an individual, as a role to access. And this list would be updated as the reality changes, a feed from Terraform, a feed from Kubernetes, or whatever else. And then Boundary will create a link from the user workstation to the resource, like logically speaking, SSH tunnel on steroids. There's no way or access to other network devices or other hosts. And the very last point is Boundary using Vault to present and create identity and credentials ephemeral. The user does not need to be known a priori at the resource, right? And then when the session ends, this whole flow collapses, and there's no way to attack any area on the network post this session. This is the boundary workflow, right? So we kind of said, I'm just going to summarize starting with a well-known authentication provider, and then carrying this identity with a single sign-on provider to authorize the user, and then boundary with Vault, create the secure channel between the user and the resource. Just to summarize, right, we talked about the 4 areas, three HashiCorp products and the SSO that we integrate with. And the main overarching principle here is this move from IP to identity. IP-driven control, identity-driven control. The single most important point here. And that is all from me. And I'll speak with you later.
Excellent, Guy. Thanks so much. I learned a lot. I always learn a lot when I listen to you. So with that, we will hear from Jens Dose, who is an editor at CIO Magazine and also a writer at Computerwoche. Over to you, Jens.
Thank you very much. There we go. Welcome all. My name is Jens Dose, editor at CIO Magazine, and I also write for the sister publication Computerwoche on everything security. So obviously Zero Trust has been a topic for me for quite some time now. As Guy already gave you an in-depth take on the technical side of Zero Trust and how HashiCorp tackles that, I want to take a step back and give you like a bird's overview on the broader topic of Zero Trust. And the first step would be looking back. So where do we come from? The term was first coined by Stephen Paul Marsh in 1994 in his doctoral thesis. 15 years later, Google launched their BeyondCorp initiative after they've been attacked by an advanced persistent threat called Operation Aurora and had lots of data stolen. 1 year later, Forrester Research revitalized the term Zero Trust and presented a first framework on what is necessary to establish Zero Trust architecture. And 2017, Gartner launched the Continuous Adaptive Risk and Trust Assessment, or CARTA for short, framework. And 1 year later, Forrester couldn't stay back, so they launched their Zero Trust Extended framework, which built on what they published 7-8 years earlier. So let's have a closer look on what these frameworks actually are about. The BeyondCorp is a user-based approach. So no more privileged corporate network. Access depends solely on the device and user credentials without the use of a VPN. This functions regardless of the user's network location. So be they in a coffee shop or at home or in the corporate network, doesn't matter. And the access to enterprise resources is fully authenticated, authorized, and encrypted based upon the device state and the user credentials. Zero Trust Extended, on the other hand, is a data-based approach. It treats all packets, network traffic, and data as untrusted, and all resources are accessed securely regardless of location. So this they have in common with the BeyondCorp approach. ZDX adopts the least privileged strategy and strictly enforces access control across the network. It inspects, monitors, and logs all traffic. And it adds automation orchestration to the whole thing to react dynamically to changes in the network if something happens. CARTA is a risk-based approach. It says that every user, device, app, and process is checked constantly for trust and risk status during a session. This trust and risk status is adapted to the context and learnings gained from each interaction within that session. And when anomalies occur, this trust is revoked and access is restricted or withdrawn entirely. Later, Gartner specified what they mean by this, by the Zero Trust Network Access, which kind of creates an identity and context-based logical access boundary around an app or a set of applications. and the access is restricted via a trust broker to a set of named entities, and the broker verifies the identity, context, and policy adherence of the specified participants before allowing access, and prohibits lateral movement elsewhere in the network and hides the rest of the network in that effect. So that's a lot to take in. Some authorities took it upon themselves to boil this down into some zero trust architecture guidelines. I will focus here on the one from the National Cybersecurity Center in the UK, because they structured it very neatly. If you want to dig deeper, you can also see the one from the National Institute of Standards and Technologies in the US. This is the special publication 800-207, Zero Trust Architecture. So what did the NCSC come up with? A zero trust architecture in general has to have a single strong source of user identity. So a user directory for the organization where accounts are created that are linked to the individuals and that enable granular access control and specific roles for each user. You need user authentication, which can be done by multi-factor authentication, single sign-on, and automated credential management. Machine authentication can be done through trusted platform modules, for example. Then you need additional context such as policy, compliance, and device health. This could be achieved, for example, via authentication with mobile device management that issues short-lived certificates to the session, or via device health attestation. Authorization policies to access an application itself can be done through single sign-on services that issues tokens to access resources, or that sets preconditions like multi-factor authentication for certain apps within the network. And the access control policies within the application can be done, for example, via multi-factor authentication to access specific sensitive data within a file store, for example. And last but not least, strong encryption and strong device configuration should be a given. But how can this all be done? Here's an example for the data-based approach. This information is from Palo Alto Networks from 2020. Other products and vendors are available. This paper kind of presents a 5-step approach on how to implement zero trust. So first, you need to define the surface you want to protect. So you have to catalog all data, applications, assets, and services. Secondly, you have to map the transaction flows in the network. You understand how traffic moves across the network and how these data, applications, assets, and services components interact with other resources in the network. Thirdly, you have to architect the zero trust network, which is the second biggest challenge in the whole process, because you have to architect the network according to the defined surface you want to protect, consisting of firewalls, microsegmentation, network inspection, intrusion prevention, and data loss prevention systems, identity access management, multi-factor authentication, and so on. The fourth step is the biggest one, which is creating the policies to prevent false positives, to prevent business processes standing still, and so on. This is tricky, but one way to do that is using the 5W1H method, or Kipling method if you want, which I will explain later. And lastly, when it all stands, you have to monitor and maintain the network. You have to survey and protocol all data traffic in the network. So going back to the policy, what is the 5W1H method? It's basically 6 questions you have to answer to define rules for one resource to talk to another and allow that traffic. And this should, in effect, enable a policy for granular enforcement so that only known and allowed traffic or legitimate application communication is allowed in the network. And these questions are: who should be accessing a resource, which defines the asserted identity? What application is the asserted identity of the packet using to access resource inside the protect surface? When is she trying to access? Where is the packet's destination? Why is the packet trying to access this resource? And how is the asserted identity of a packet accessing the protect surface via a specific application? And if you answer all these, you can kind of mesh out a policy for your zero trust network. Going to the technology, which solutions, tools, systems do you need, which are recommended? And here Forrester again came up with a neat little matrix, and they say you need a system needs to have at least 3 of the following categories plus API integration capabilities to be considered for zero trust. And these categories are in the network space, it has to enable network isolation, segmentation, and security. In the data space, you need to enable data categorization, schemes, isolation, encryption, and control. It has to secure the users of the network and the business infrastructure and reduce the threat that users create. So insider threat is also an issue. It has to secure cloud networks and apps and so on, which are used to make the business operate technically. It has to automate and orchestrate zero trust principles and provide more control of disparate systems. And last but not least, we need analytics and data points to eliminate dark corners of the systems and infrastructure, so shadow IT, for example. Are we doing that? No, we are not. We did some studies by IDG, and we asked last year IT security C-level people in the DACH region on, is zero trust a topic? And over 90% said yes. So they either have implemented it, they are implementing, or plan to implement. Only 7% have nothing to do with zero trust. But at the same time, the priorities for the security investments are in averting attacks in generally, network security, cloud security, and identity and access management, which is the key technology for zero trust, is at position 10. So then we asked regarding the cloud security, which is a main driver for zero trust, how enterprises are handling this specific kind of security, and which technical measures they implement to ensure cloud security. And they said data encryption, password management, identity access management, and at position 12, zero trust. So what does this mean? This points to that zero trust as a whole concept in the company is too big, too complex to tackle in one go. So companies are picking out little bits and pieces that you need to ensure the zero trust infrastructure and kind of building it brick by brick. So we still have a way to go until zero trust as a concept is has reached the companies. What will come in the future? In the next few years, dynamic and one-off secrets per session, as Guy described, will be more public and in more solutions. We will have continuous authentication. So you combine application and IPA monitoring with identity solution to realize the CARDA approach of giving and taking trust away during a session. And Forrester says that Zero Trust approaches for securing IoT and OT environments will become more proliferant, and that Zero Trust architectures and technology platforms that help to enable Zero Trust will also come to light. So this last thing will tackle the problem of just bits and pieces, not the whole thing. Thank you very much. And now, with further ado, I think we should go to the panel discussion. So yeah, I would. Yeah, sorry, Guy.
Thank you. This is with Conrad and Ingo.
Yeah, right. So we have Guy Sayar, which you already know, and I'd like to greet Ingo Sauerzapft, Development Manager at SAP, and Conrad Ilgmann, Partner Technology Strategist, SIV at Microsoft. So just to kick us off, the first question, Ingo, you as a user have like first-hand experience with Zero Trust. Very shortly, what did you do and how did you do it?
Yeah, so maybe I'll actually have to elaborate a little more. I am actually responsible for source code or for the operation of source code management system inside SAP. So I'm sort of like a hybrid within the world. I'm not quite a network person, have nothing really to do with building out the network, but I'm also not just an end user because I'm running a service that sort of like is on that network. And at SAP, a number of years ago, the company has decided to expand beyond its own infrastructure as a service provider and start deploying software, not only on that, but also on like the major infrastructure as a service providers. And hence, with that, exactly what Guy pointed out happened, that people were sort of like expanding beyond the SAP corporate network and into other networks, and more often than previously crossed that border between what was perceived as a well-guarded thing and to a world that was not guarded at all. And not only did they go out, but eventually they also wanted to come back. And with that, more requests opened up to sort of like make more calls into the network or into the SAP network. And with that, over the years, I think the boundaries between the two sort of like blurred, especially for people who are not that network savvy and are not really like have a hard time understanding what's inside and what's outside. And naturally, of course, that sort of like led to making the internal network more secure. And what I've seen in particular with my services is that the services that used to be more open internally, where we, for instance, may have had anonymous access to certain pieces, sort of like were closed up, and they were made more stringent to the point where they are actually as closed as a service that would run outside of the network. We have also started to invest more in sort of like finding loopholes, in particular on our services like code repositories, where accidentally people have committed secrets into source code systems they didn't even know, and where previously we did not sort of like scan for these things. Naturally, eventually the thing started to become a requirement, and we started scanning for secrets inside code. And sure enough, of course, you'll find if you look, because that's just a natural thing, happens very fast, in particular in source code repositories that sort of like don't forget anything, like Git, for instance, where you have the history and you can always walk back. You would always find some sort of like a secret somewhere, and with that open up your system. And naturally, we then progressed to the next step, and not only trying to find proactively these things, but also offering people a feature or a functionality that allowed them to become more dynamic in what secrets mean to them, and then eventually also make them more, exactly, more dynamic. And with that, we, as the source code management system, started thinking about that and ended up deploying Vault as one of the options that would allow people to sort of like move from static secrets more to dynamic secrets. That's sort of like the story that I have seen and encountered in the past 2 to 3 years, I would say.
Conrad, do you see the same thing in the markets and other companies? What is your view on that?
On application development, definitely. So my work is usually with partners, like SAP or others in the German market. So I'm working on applications which they host on our platform, and they're the topic of making sure that the credentials are stored safely, that managed identities are used. So what further was mentioned as application machine authentication is an important topic, that you don't need service users anymore, or can get rid of those, that you check the supply chain. I guess most of us have in mind that there was this SolarWinds breach just in the 1 or 2 months ago, where nearly everybody was hacked. So all the big ones, including us, thousands of companies, and that's because of the supply chain packages which were actually corrupted, and more tools are now used and needed to verify, okay, what are you building on top on? And whenever you do modern application development, you are building on top of libraries which are not in your control, and which is not possible to check from ground up. So you need tools, you need automation to check those. And of course, you also, what was mentioned, you need to assume breach. So it can happen to everybody. There's no way that you can completely make your environment that secure that you will never be attacked or never be breached. So in that case, you need a good recovery strategy, and also good tools to actually show, okay, what has been breached, what is the effect, what data has been stolen, and so on.
All right. Thank you. We do have some questions from the audience, so maybe Conrad, Guy, and Ingo, you can say something about it. What is the biggest changes from today's state to an art of zero trust? So, what is the essence that makes zero trust so different?
What makes zero trust, I guess the biggest difference is you are going by applications, by services. So whenever you develop something for each service, for each application, you have to take security in mind. And perhaps 10 years ago, when you were building an application inside your perimeter, inside your network, you were not so concerned about this, because there was always this firewall around you, which ensured protection. Zero trust in that way is totally difficult. Different. You need more knowledge on the security side when you build applications. You need, of course, because there are not that many security experts available and around. You need to automate. You need to build on existing structure. There are, of course, also artificial intelligence which can help. Recommendation advisors which actually scan your applications and make sure that you follow the important principles.
I think that's exactly the biggest change. Yeah. So we view a service that we deliver today as an isolated thing that's not living on one network, but that has its own little perimeter that we deploy, we decide, we control. For instance, if I look at source code repositories that we provision inside the SAP network some years ago, we never cared about any network boundaries or like how do we get into the service, or how do we come out of the service? It was an SSH, and it had a bunch of machines, and that was basically it. And today you have, when you design that, we as the service sort of like start thinking about, okay, is that a VPC? What goes inside the VPC? What stays out of the VPC? How do I get into that VPC? Can I make it more secure? What points do I open up? What network points do I open up? Which ones do I close? Which ones can I talk from the service to others? That was not the case some years ago. And with that, I always translate it into, if you look at the map where we used to have a continent, and everybody was living on that continent, these days it looks a lot more like islands, many islands that are sort of like loosely connected to each other. And I think if you put that picture in your head, it sort of like brings out probably the most significant change that.
So I have a question for you, Ingo, actually. I think, when you said, and I agree with you, that like more knowledge needs to happen and things can no longer be done transparently by the infrastructure, by a different team. Like we talked about it a little bit, and Conrad said as well, right? And there was this notion, this is a little bit from my experience, right? There was a notion of, okay, an application needs to go to the cloud, let's review it. But then when you design an application, will it go to the cloud? Maybe not now, maybe later. Okay, so let's figure out a set of rules that all applications will follow. And then, as you said, right, even on-prem, they will start being more and more secure. And maybe future-proof them.
Yeah, definitely. I mean, like, even if we, for instance, have a deployment today, we treat it like cloud deployment inside the network. So it's not really this, okay, 3 servers and off you go anymore. It's more like, okay, I really need, what are my boundaries around the service, regardless of whether I am inside the SAP network or I am deploying it outside on an infrastructure as a service provider, for instance. Because they are literally identical. I mean, at least from a mindset point of view. Maybe if I would look underneath the hood, they probably still have differences there. And but for us as a service provider, it's the same.
So I think that you said the mindset, the mental model is simpler. There's more work, and you say, what? I don't need to secure something, but like there are less decisions to make. And I think people get it. But my question is, from your experience, right? Any tips on how to start? People understand the model. People, want to be more secure, but they kind of look at their existing state and they say, all right, you're talking about ephemeral identities, and everything is dynamic. How do I start? What is like? This is what I want to be in 5 years. What do I, how would I get there? What do I do next 6 months? Next 3 months? Few tips on that regard.
I think Conrad's definitely right in saying there is more knowledge necessary on that security layer level. And what we did in the past, we definitely started with this isolation of an individual service. So when we deployed a new service, we were thinking in terms of how is this thing isolated from everything else, regardless of whether it's inside or outside. And then only after we had accomplished that and we sort of like knew our way around it and we started deploying things on an infrastructure as a service provider, and then we used automations for that to accomplish it, so that we didn't have to do it manually and we didn't have to do manual changes, but we actually used like a tool like Terraform, for instance, that would allow us to deploy it as a set. Only then we sort of like move to the next level. And I think that's sort of like, at least from how I see it, a natural progression where it goes from this deploy this service as a unit that's isolated, do that in an automated way, and then look inside the service and then sort of like see, how do I secure the service internally? How do I make access to it maybe more dynamic or more on a user level and not so much on a network level? And then from that, naturally, depending, of course, what that service is, it progresses. And with us, it was, of course, we were hosting code, or we're still hosting code today. And people just push secrets to it, whether we want it or not. That just happens. And so we sort of like have to take care of that as well. And we have to look inside the data that we carry for SAP on our services, and then basically make people aware that things have happened. And I think that was sort of like, at least for us, and that the natural progression that that happened from like a bunch of servers that are on a network we didn't even know what it looked like, to a little island that's like secured in itself, and then eventually also inside the island we started cleaning up, if you want to take metaphors.
Yeah, you know, like you change the wheels, you upgrade the wheels as the bus goes, right? I mean, you don't stop
exactly, definitely
SAP to implement Zero Trust.
Yes.
And like, you know, I found one way to do it is bottom up and kind of building blocks and then moving up, as you said, right? The IaaS layer, the Terraform, the automation, the secrets. And we kind of talk about that in the crawl, walk, run model.
Yeah, exactly.
Yeah, for me, first it starts with people. So I guess you need to educate your developers, your teams, your project managers to at least have the basic knowledge and standards. Yeah, the real deep experts you might be able to get from partners. You know, just perhaps the ones you listed. Yeah, which can provide experts which are not that easy to find on the market, but the development teams, operations teams need to have the basic knowledge, and from that you can start. Yeah, first of all, using of course the tools you already have, Defender, antivirus, firewalls. But then you come to the point, okay, where do I start? Especially if you do new deployments, and I would always try to create a lighthouse project. Take a project where you try to start new, where we want to implement a secure application using Zero Trust. And a good starting point, I know, is the landing zones. We offer together with HashiCorp on Azure, where you have predefined Terraform deployment scripts, where you have different layers of security already built in, where you have the policies already applied, and then you can use this to adjust to your company and to build your own security practice on top of that.
Yeah, cool. So I want to take a question from the audience. We have some questions coming in, and this is a question, you know, again for you, Ingo, because it's a question I like, and you know, for the application developers in the room, right? When you develop an application, and this is true, when you develop an application, we are in the early days, you need the power. And, you know, how do you enable developers without giving him the power? Sometimes the power that they need is not something that you're comfortable with in terms of access and debugging and whatever else. And, you know, this notion of a developer, but I need to debug my thing before it goes to prod. When it is prod, okay, let it run with no access and it's all secure, but I need it now. Have you, like, how do you deal with this kind of situation? I saw it many times. I don't know if you have something that you can share with us.
Well, the way we do it, and I can only, of course, reflect on what we do, is we oftentimes isolate it by, let's say, groups or let's take, for instance, Google as an example. Google Cloud Platform. There, what we do, for instance, is we have different projects, and there's a production project, and there's a staging project, and then there is a development project. And of course, many more people have access to the development project. Only a handful of people have access to the staging project, and then even fewer people have access to the production project. And what we do is, of course, we use tools like Terraform, for instance, to build everything out in a project that's very open, where many people can access it, but it's automated and repeatable in the same way that you did it in development, in staging, and in production as well. And with that sort of approach, you can take what the developer has built and move it to staging and move it to production without the need of that person coming along and having access to these environments, because it is repeatable. And of course, sometimes you can't, I mean, like there's probably things where you would sort of like have a gray zone where you have anomalies or stuff like that, that you just can't, you know, replicate in dev. Of course, that's the exception, but it's probably more an exception than the norm, as it used to be in the past, where like the guy just had to go into the production environment to sort of like fix it and make the changes there as well. Does that make sense to you?
Yeah.
Yeah,
and also, you know, from my experience, you also kind of introduce new and modern tools, like, you know, consume logs in a better way, remote debugging in a better way, and
that
so on.
too. Yes, of course. Yeah, absolutely.
Thanks.
In the same vein, I want to ask Conrad. So there's a lot of complexity in setting up Zero Trust. So with new tools, services to use. Can you give any insight on where enterprises can start in the best case? So do they do it like Ingo with kind of a lighthouse project and work from there, or what is your experience in the market?
Lighthouse projects is definitely the usual way. So you first, especially when you do application development in the cloud for the first time, it's usually a good start, but also can also start later. So taking an application and trying to follow the zero trust principles on that application. But the important part, if you do this, of course, you need to make this repeatable. So just like Ingo mentioned, yeah, you should use infrastructure as code. You need to automate the policies, yeah, and make this a repeatable pattern. And what we advise our customers and partners to do is to build out the security practice, yeah, to have people which are then building the framework, the layer 0 infrastructure templates, yeah, which then can be used by all other applications and development teams inside the company. Yeah, so that those teams already know, okay, if I use this template, if I use this approach, this is secure, this is has already the policies enforced, this is something our operations teams can work with and know how to work with. So I have less to think about as a developer and concentrate on the topics I do. Yeah. It's getting more complex, but there are ways to reduce this complexity.
And that's definitely also an approach that sort of like reduces the overhead in the security team, because you know you have templates, you know they are built to a standard that is fine with them. And then if you reuse those, you don't need to sort of like go over every security concept in detail anymore, because you can sort of like rely on them using the template that, you know, the base foundation is set correctly.
So last question for the last minute from the audience: what can be done post a detected threat or breach? So if the thing happened.
Yeah, hopefully you have already a concept and implemented. Yeah, so zero trust means assume breach. Yeah, this means also, okay, you should have a strategy. What happens if this happens? Yeah, one thing of course is recovery. Yeah, we had those cases. Yeah, ransomware attacks where customers, yeah, they were attacked. Business went down for days, and they were negotiating with the attackers. They were even paid them. Yeah, they got the keys to encrypt again their data, but it took too long. Yeah, the encryption would have taken days to do. So what they at the end did, they used their backups and created the system again. Yeah. So if you of course have good recovery strategies, yeah, if you also of course test this, yeah, there's this old saying, backup never fails, recovery does. Then you have the chance, yeah, to react quickly. And of course, like Ingo mentioned, if you have those islands, yeah, when you are attacked, yeah, think about GDPR. You might need to inform authorities. You might need to inform the public. If you know, okay, this attack has been restricted to this area, you are much better to inform the people involved. The worst thing which can happen, you are breached from the inside, in your open network, and do not know which systems have all been attacked, because there's no boundary in between anymore, between all kinds of systems.
Yeah, that's great. That's great.
Thank you so much. This is Thomas here. Conrad, Ingo, Jens, and Guy. I'm pretty sure we could talk for another hour or two. I mean, really, really interesting discussion. But what I would suggest is you just continue the discussion later on in the party and move on with the agenda. Next up is Lance Haig. Lance is our Solutions Director for Germany, Austria, and Switzerland. And Lance is going to give us an overview of the HashiCorp Roadmap to Zero Trust. Lance, over to you.
Thanks, Thomas. Appreciate it. And thank you, everybody in the panel. It was really interesting discussion. And as Thomas says, we could keep going for hours. I wanted to jump in with a few questions, but we had some great ones from the people outside in the Q&A. And I think we should definitely follow these up. If anybody had questions that weren't answered, please join the chat afterwards, or the event afterwards. And I'm sure we can get people discussing. We will have technical people and everybody else there at the same time. So let me, because we could kind of short on time, I'm going to jump into my presentation. Are you able to see my notes, my slides?
We can, Lance, yes.
Awesome, fantastic. So as Thomas mentioned, I'm going to be giving you a bit of a roadmap to Zero Trust. Now, the idea, I mean, we've spoken about the theory part of this and how this will work in future, and how this has been a talking point for a few months now. But what I wanted to highlight was how HashiCorp's journey has kind of meshed all this together with the products that we're talking about today. And I thought I would go through, myself, so I'm not going to do that. Thomas has done that for me. We're going to call it applied Zero Trust. How did we apply the Zero Trust? What are the things that are part of an applied Zero Trust? And there are basically three key points which everybody's kind of spoken about, so I'm just going to reiterate them again. The first one is the principle of least privilege. Every machine in your network should only, or machine or person, sorry, should have only access to the things and the items and the services that they are required and need to have access for only the amount of time that they need to have access. So it's kind of restrict down the time that a secret or a access is granted to the absolute minimum and the absolute minimum of permissions. So this will answer some of those questions about how do you get on after a breach. This is kind of like preventing the breach before it happened, because you cannot get access for a very long time to kind of do that big data mining, big environments. And then the second one was never trust, always verify. Now, this doesn't say that you don't trust anybody. You just always verify that the person that you expect to be on the other end of whatever's happening, or the system, is actually that system. So they should always authenticate themselves, and must always be explicitly authorized to access whatever they need to access, whether it's credentials, APIs, VMs, databases, whatever that is, right? And then the third one, as we've mentioned before, really important, assume breach, because it helps to then give the person, when someone gets into the system, the smallest attack surface they can even find, because you've assumed that you've already been breached, no matter that you haven't. So these are the three pillars that are very good. So if you look at them in general together, it makes it really important that you can keep this in mind when you start working with your Zero Trust and your journey to Zero Trust with your businesses, because this is where you just need to keep these things in mind and make it much easier. As we've said before, Zero Trust is like a way of doing business, and there are many parts that are kind of covered by different parts of or different operating or different systems and different solutions, different environments. And one of the really key parts of this is actually getting or granting secrets or credentials in a just-in-time manner. So what we talk about is that we have, for example, we need to have identity-driven controls, which I think this slide you will recognize from Guy's presentation, we'll have these things where you want machine-to-machine authorization. So you want to make sure that the authorization is done with machines. And so every machine identifies itself to the other, to wherever it's going to be connecting to. You want machine-to-machine access to be encrypted so that you have the channels encrypted, and people listening on the wire won't be able to see and read what's coming across the wire between the machines. The second thing is obviously you want to have your human-to-machine access managed by this identity-driven controls. And then the final thing, of course, is the human authentication authorization, because you want single sign-on for the humans as well to make sure that they are who they say they are. So this is really, you need to have you provide these details just in time. In other words, when someone needs it, they get it at that time, and then it goes away and it cannot be used again. So that secret or access is removed. So how does HashiCorp's products fit into this environment? So we start with Vault. Now, Vault was kind of, in 2016, became this high resilient management tool for introducing zero-touch identification, which means that it could create dynamic secrets, it could identify workloads. And so you could have a database secret that is generated every time an application needs to get it. And by the time the request is finished, that secret never exists anymore. So that means to me that the attack surface goes down. Then in 2017, we started looking at the DevOps workflows and the scale to meet regulatory requirements. So we wanted to get kind of FIPS compliance there, so that it allows us to have these regulatory backers to say, yes, we are certified to support these kinds of things. Then in 2018, we became like the market standard for secrets management. If you look and you discuss with a lot of people, we kind of started this journey with secrets management, and people looked at it and said, okay, fine, this is a really good tool. It makes it really easy to use. And then we carried on from there. And then in 2019, we added advanced data protection and a few other situations in that, other options. For example, encryption in transit, encryption at rest, format preserving encryption and masking, and then obviously tokenization, where you can tokenize your data that is completely irreversible, but can be reversed by Vault. So it would be very good to be able to access the system. And then we look at console. Now, console so we look at Vault started in 2016, console in 2017. Now, console is your networking kind of security layer, part of the Zero Trust trio, as we call it. And, or as I call it, sorry. And it's a service management toolkit. It allows service registration and health checking and these type of things in 2017. And then in 2018, we realized that people are going to be doing multi-data centers environments, multi-data center communication. And so we added WAN federation to the data center. So now you can have two console clusters talking to each other and allowing the traffic between them to be encrypted. And then in 2019, we added to layer 7 observability and service proxies. And this allowed us to view what the data is doing and allowing us to then make adjustments as to what's happening with the data when it's happening. But all this communication obviously works with sidecars that enable you to encrypt the traffic between point A and point B, and you can restrict that these web servers can only speak to that database on this through this connection. So it makes it a much more or a smaller attack surface when it comes to the Zero Trust environment, or the Zero Trust methodologies. And then finally, what we did is we looked at the market and we said, okay, fine, how about we start looking at something that's going to be more for the humans, right? We saw a lot of customers saying, hey, we like what Vault does, we like what Console does, but we want something for humans as well. And so in 2020, we released Boundary, and it's basically a client server solution where you have as guys said earlier, you allow humans to authenticate themselves against a identity source and then get granted at that time with the right secrets that they never see. So they never get given the secret for the service they're accessing. They get granted that access and can use this service for the time that they're allotted or allowed within the policies and framework. And in 2021, we started adding, for example, we've just literally released OIDC integration and secrets injections for Vault and other kind of solutions. And this is, as everybody's mentioned, this boundary is growing. We're listening to the market and we're growing and we're making things and we're doing and creating more for our customers. And I'm really excited about where this is going to go. because it kind of brings together this whole Zero Trust thought pattern, in that people, or you use Vault and Console to create that machine kind of identity, authentication and access for Zero Trust, but then your boundary. And I think there was a question about how do you, get your users, how do you figure out if there's an internal attacker? Well, if you had something like boundary, you would know exactly what that person connected to, when they connected, and they would have to get permission to do that. So you would be able to find out exactly what that was and be able to remedy what was there. And then what I am going to talk about now is kind of like, this is what it would be in a real world scenario. We're talking about a system. In this scenario, it's going to be a Go application that needs to talk to a backend database system. And we are going to be using Vault in this mix at this stage. So what we have first is the Go application will go and create a request to Vault to say, hey, I need database credentials to be able to log into the database. The Vault will give it access, and the Go application will have database, the credentials it needs to get through to the database. A user, for example, in this case, we can use a credit card number. A user will submit his credit card number to the application via the interface. This credit card number is then given to Vault to say, please encrypt this or tokenize this. So in this case, it's an encryption where it gives back a format encrypted. So it still looks like a credit card, but it is completely non-related to the original credit card. So it's the numbers that are generated there are random, but they are unencryptable for Vault. This encrypted data is given back to the application. The application then connects via Envoy and Console. So it creates this TLS encrypted pathway to the database. This pathway is then, this data passes across there now already encrypted before it even gets to the database. It gets to the other side of the Envoy proxy, so that's all TLS encrypted, so it's not being able to be found. And then Console verifies that the Golang the application on our left-hand side may talk to it. So it says, hey, does this Go application have access to talk to this database? It proves and says, yes, it does. And it basically writes this encrypted database record into the database. Now, you think about this as a savior part is that you don't have to change your database structure. You don't have to change your schema in your database. You just add this application where it encrypts the traffic while it's going across there, so that you have an encrypted field in your database. So even if someone did take that, they wouldn't be able to use it because it's actually an encrypted database credential. What you can also then do to improve or even increase the encryption is that you can use our Vault's KMIP secret engine to enable you to protect the database files that are sitting on whichever service, on every data storage device, to encrypt it with KMIP encryption keys as well. So Vault will be able to provide those keys to the database. And so if somebody was able to take a copy of your disk, they wouldn't be able to unencrypt it, even if they had it, because they would need your Vault, which is sitting with you, and they wouldn't be able to use that in general. And then we're going to need to handle, we have the security request where a user would like to have access to the database for some kind of reason, whichever that may be. So their user using boundary would request to Vault, say, Vault, please, can I have RDP access to the database? And basically, Vault, the database comes back and gets given, or at least Vault comes back and gives the user this access to be able to go through the proxy system into the database and be able to do the job they need to do for the time that they need to do it. And one of the key factors in this scenario is that the credentials, that the person that is requesting these credentials never sees the credentials. So it never ever, well, a seen credential is a compromised credential, so they cannot see it. It's always handled by the backend systems. And it is a short-lived secret and it gets removed once the session is finished. And that is the short and sweet of it. And I've got 3 minutes left on my time, so I think I made some time back, Thomas. Yeah.
It is absolutely awesome. Thanks, Lance.
Apologies for rushing, but I just thought we were running out of time.
That's all good. That's all good. Gives us a bit more time to drink in a couple of minutes. Thank you, Lance. And we are almost at the end of today's event. And first of all, I would really like to thank everybody who joined today's webinar for the great questions and the questions which have been asked. And I would also like to thank all the speakers and the panelists. So thanks so much to Conrad, Ingo, Jens, Guy, and Lance, giving this really, really good insights and showing us how that whole zero trust topic fits together and how one can make it reality. So it's not only a new marketing term, it's not only another thing technology companies are walking around, but it can be really realized. It is realized at many organizations already. And especially think the slide Lance showed at the very beginning shows nicely how that all fits together in practice. So I hope everyone enjoyed today's event and the discussions on Zero Trust security. To get started with Zero Trust security, I would really like to point out these few links to you. So first of all, there is a really nice comprehensive white paper we have, which you will find under this link, and we will also post it in the chat, that link here, that you don't have to type it. That, as I said, summarizes everything. That's something for a glass of wine or a beer later to have a look at. Also, if you would like to talk to anybody of the HashiCorp team, the easiest way to reach out to us is hashicorp.com/contact-sales. And don't be afraid. It doesn't necessarily mean that you immediately want to sell you anything, but that's also the gateway to get to Lance's team based on any technical questions. So really, really happy talking to you. And last but not least, I hope you enjoyed today's event. And if you enjoyed today's event, I'm pretty sure you will also enjoy the HashiConf EU. So that's the European version of our HashiCorp event, which is from June 8th to June 11th. And there will be, without doing any spoiling now, there will be a few great announcements you all, I think, will be looking forward to. So have a look at that website as well, register and take part here as well.